The forces in the universe, four fundamental forces govern the interactions between all matter and energy: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. These forces, each distinct in their characteristics and effects, shape the behavior of everything from the smallest subatomic particles to the largest cosmic structures. Gravity is perhaps the most familiar force, responsible for the attraction between masses. It is the force that causes objects to fall to the ground, keeps planets in orbit around stars, and binds galaxies together. Despite its pervasive influence, gravity is actually the weakest of the four forces. Its strength decreases with distance, but never entirely disappears, ensuring that it plays a crucial role in the structure and dynamics of the universe. Electromagnetism is a force that acts between electrically charged particles. It is the force behind electricity, magnetism, and light. This force is much stronger than gravity and operates over a wide range of distances. Electromagnetism is responsible for holding atoms and molecules together, enabling the formation of matter. It also governs the interactions of charged particles, which are the basis for the operation of all electronic devices and the transmission of electromagnetic waves, including radio waves, microwaves, and visible light. The strong nuclear force is the most powerful force, but it acts only over very short distances, roughly the size of an atomic nucleus. This force binds protons and neutrons together in the nucleus of an atom, overcoming the electromagnetic repulsion between the positively charged protons. Without the strong nuclear force, atomic nuclei would not hold together, and matter as we know it would not exist. This force also powers the sun and other stars through nuclear fusion, providing the energy that supports life on Earth. Lastly, the weak nuclear force is responsible for certain types of radioactive decay and nuclear reactions. It operates at a very short range, even smaller than the strong nuclear force, and is crucial in the process of nuclear fusion in stars and in the decay of unstable particles. The weak force plays a key role in the sun's energy production and in the mechanisms that govern the life cycle of stars. Additionally, it is involved in particle interactions that are fundamental to the universe's structure and evolution. Together, these four fundamental forces create the complex and dynamic interactions that govern the physical world. From holding atoms together to shaping galaxies, they are essential to the existence and behavior of everything in the universe. In one perspective, chaos emerges from the interplay between forces of attraction and forces of repulsion. If there were a scenario with absolute forces of attraction and no repulsive forces, all matter would collapse into a single, massive entity existing indefinitely. A universe governed solely by attraction would be compressed to unprecedented densities, lacking the stability necessary for the formation of complex structures. This would likely result in a universe where energy, matter, and fundamental forces interact in ways that challenge the principles currently underlying our understanding of physics. Conversely, if only forces of repulsion existed without any attraction, the universe would be filled with fundamental particles of matter and energy, each isolated from others, lacking any cohesive structure. Alternatively, matter might dissipate into pure energy, radiating outward and dispersing indefinitely. This thought experiment highlights the delicate balance required for the universe as we know it to exist. The universe is dynamic because there are forces of attraction and forces of repulsion to varying degrees, and therefore entities will form and deform. The planets, moon, solar systems, and constellations keep forming and deforming due to the dynamics between the forces of attraction and repulsion.